us go back and take a look, right? Is that fair? Some of us go back and look at these. Yeah, some of us do. Bravo. Okay. So I'm going to go back to my screen share again. Thank you for that. And okay, so let's say that your starting salary is 60 grand. And there he is. Okay, good. Now everybody's here. Now I can do my job. All right, so you're $60,000 a year, and let's say that your boss says that you're going to get a 3.4% raise per year, right? What would my exponential equation look like? Because we're using y equals ab to the x. So what does my equation look like when I'm trying to figure out my salary, right? My salary equation. What does that look like? You've been doing these problems. Everybody, if I call on one of you, somebody should be able to tell me. So Lena, I'm going to call on you. What does my equation look like for this, honey?
The equation is y equals 60,000 parentheses 1.034 parentheses to the x power.
Absolutely, right? Because you're getting 3.4% per year. So can somebody do me a favor and get me what your salary is after the first year, like going into year 2? It would be 60,000. You're all going to need your calculators, so make sure they're out and about, right? And if we do that to the first power, what do we wind up with? Somebody spew an answer out at me.
62,040.
62,040. And how much cents do you get?
None.
No sense.
None.
There are no cents. Okay. So then if you wanted to figure out what you would get the following year, wouldn't we use this guy right here? Because we're making 3.4% on this new amount, right? Are you all with me? So now it would be your $62,040. And you're getting 3.4% on that now. So what would that give me if you take that and you multiply it by whatever? What's my new value? What's your new salary?
64,149.
64,149.
0.36.
And 36 cents, guys. It's money. Say 36 cents. You sound like knuckleheads, right? So then if you do the following year, it's going to be 3.4% based on your 149.36, right? 3.4. So in other words, that means my new salary now is how much?
66,330 and 44 cents.
Beautiful. Okay. So in other words, do you see how you're making money on your money? Yes? Say it with me. Making money on your money.
Making money on
Making money on
That's
your money.
called compound interest. That's what makes compound interest so fabulous. That's supposed to say interest, by the way. This is compound interest, is where you're making money on your money. So in other words, you know, your raise is based on what your salary is each time. And we found out that this is the fastest way to find out like what you would be making over due time. But it came from this, that, you know, after your first year, like your new salary is 62 and change. After the following year, it's 64 and change, because your salary went up 3.4% based on this amount, right? This salary here is based on this amount that you're getting 3.4% for. Does everybody see that? So that's why compound interest rocks, because you're making money on your money. That's what makes it fabulous. That's what it means by compounding. Okay? Are you ready?
Mm-hmm.
Are you all ready?
Mm-hmm.
Please say yes.
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 All right. So I don't know how many of you saw this yet, but if you didn't, it's okay. I don't know how you did it. You raked in $1,000 for your birthday. I have no idea how you managed to rake in $1,000. People must really love you. So now you know what? You're like, okay, I'm going to go put that in a bank. So there's this bank called LaLa Land. I'm calling this bank called LaLa Land, and you're going to see why in a second. Because in LaLa Land Bank, they are offering you an annual interest rate of 100%. How much is going to be in your account in a year? How much is going to be in your account in a year if they're giving you 100% interest?
$1,000.
$2,000, okay? Now, I'm calling it LaLa Land Bank because do you know what the interest rates are for savings accounts in banks? Do you know what they are?
10%?
I wish.
15%?
How much?
Like 15-ish?
15%?
Like,
Oh, Lena, I would keep my money in the bank in a heartbeat.
Are we
Anybody?
talking
0.11?
It's like one or
They're like 0.11%.
Oh,
Yeah, so banks
I
are
thought
like
you were talking
0.11%. Okay, so let's talk about this, right? So if we use our y equals AB to the x power, right? A represents our initial amount, and B represents our rate of growth, yes? So over here in this problem over here, we have y is equal to 1,000, right? Times 1 plus 100%. So that means I'm adding 1, right? Which is why it's $2,000 after a year. You're making $2,000, right? Or you have $2,000. You earn $1,000 in interest. That's why it's called LaLa Land, because realistically out in the world right now, it's 0.11%. So if they were to compound it annually, realistically, what would be the actual amount? If it's 0.11% and not 100%.
1,011.
What is it?
1,011.
I don't think it, no, I don't think it is.
Oh,
So you
never
do.
I got it wrong. It
It's
was like
0.11%. So in this case, this would be y is equal to 1,000, right? Times 1 plus. You're not putting 0.11 in here. You're put 0.0011 to the first power. Do you see that?
Isn't that 11? Right.
no.
Wait, 1001.1.
1001.1.
Yeah, it's
So that means how much in interest did you actually just make?
$1.10.
$1.10. You can't get a cup of coffee for $1.10. You could get a bag of chips, but think about that. 12 months later, you only made $1.10 in interest. That is what the banks are offering these days. How many of you are saying kaput kapui, that stinks, right? You can say it on 2, 3, 1, 2, 3. We're all going to yell, that stinks. 1, 2, 3. Right?
That stinks.
It does. Okay. But let's go back to LaLa Land, because LaLa Land feels really good. Like, I want to hang out in LaLa Land. So that's where I want to be right now. Okay. So this LaLa Land is like, we're going to give you an annual interest rate of 100%. So you're like, okay, but you want to double my money in a year? That's wonderful. But I think I have a better challenge. So knowing a sucker when you see one, you go back to LaLa Land Bank and you request if they could compound the interest semi-annually. How many times a year is that? Semi-annually. Twice a year. So do 50% for the first 6 months and then 50% for the second 6 months. Is that a better deal, yes or no?
Yes.
How many of you are like, I think it's a better deal? Yell out, I think it's a better deal if you think it's a better deal.
I think it's a
I think it's a
better
I
better
do
deal.
too, okay? How much is it? How much are you going to have after that 1 year? How much are you going to have after that 1 year?
2,250.
2,250. How did you get 2,250?
I did 1,000 times 1.5 times 1.5.
Yes. Look at you. Okay, 1.5 times 1.5, exactly. So is it fair to say then that I could almost do it where I do 1,000, right? Times 1 plus 0.5 to the second power. Is everybody okay with what I did there?
Mhm.
Okay, good. All right, and that gives you 2,250. So we just compounded, instead of compounding once a year, we compounded twice a year, and we got another $250 by compounding twice a year, right? So, LaLa Land, you want to walk back in and see if you can sucker them even more to see, if I compound more, will I be able to make more? So now you go to LaLa Land and you convince them to compound the interest every month. Okay? So now we're compounding the interest every month. So now over here, I just want to show you guys that when you're doing this, right, it's going to be 1,000 times 1 plus. Now this 1 represents the initial amount that you're putting in, right? This number is how much interest you're going to be making. So now, because it's 100% interest, you're breaking it up into how many months or how many pieces?
12.
12 pieces. And you're compounding it how many times a year?
12.
12. So when you look at this, so this is where this number comes from. So based on, this is showing you that you're compounding the interest every single month, because this right here represents the annual interest rate, which is 100%, and 100% written as a decimal is 1. If you're with me, clap 3 times. Right? And since you're compounding it every single month, you have to take it and divide it into 12 pieces, because that's how many times you're compounding it. And this is how many times during that course of the year that you are compounding it. What is the new amount if you compound it 12 times a year?
2,613.04.
So 200, is that right? 2613.04? Yeah.
Mhm.
Holy crap, look at that jump. So instead of compounding twice a year, we compounded 12 times a year, and look at that jump, right? Let's get crazy. Let's compound this every day. Let's compound this every day, because it just feels like every time we're doing it, it seems to be more and more and more. So let's see what happens every day. How many days are in a year?
365.
365. So I'm going to wait for you guys to figure out what's going on with that 365.
Wait, if you do it with your calculator, it like breaks and it just says 0.
What?
Like if you do 1 divided by 3, oh wait, never mind.
No, it doesn't. You get a decimal. It's a long, long decimal, but it's still a decimal, right? Trust in it. Does somebody want to give me the, when you're done, when you're ready, what the equation is?
2000. Oh, the equation.
Yeah, just give me the equation and we'll get the amount. Go.
1,000 times 1 plus.
Oh, sorry. 1,000. What
1,000
happens?
times
My pen goes crazy. It has a mind of its own. 1 plus 1 over
365
time to the.
to the power of 365.
And what did you come up with there, Sunshine?
2,714.67.
And can you say 67 cents? People sound like
0.5 cent.
right?
0.5
67 cents.
It's 57.
57 cents. Okay. So it's 57. So again, now we're so it seems like the more we compound, the more we make. Is that, you see what everybody see that? Okay. So now that's super interesting. So let's get even crazier. So instead of compounding interest every day, let's say we're going to break this down. Let's say that you get crazy and you're somebody who's like, well, I want to compound interest twice a day. Someone's like, I want to compound interest every hour. Someone's like, I want to compound interest every minute. Somebody wants to compound interest every second. Okay. Now, I'm going to break this up. If your name goes from A through F, you're going to compound the interest twice a day. If your name goes from G to K, you guys are going to compound the interest every hour. If you're from P, if you're P through S, you're going to compound every minute. And then if anything past S, you're going to compound every second. Okay? So based on your last name, you're going to be doing one of those 4. And I'm just curious, is that the more we compound, are we getting that insane increase, or is something else interesting happening? Look at this. Yeah, there it goes again. Okay, so for the first one, who's got twice a day for me? Somebody give me an answer.
2,716 and 42 cents.
Beautiful. Can I have every hour?
2,718 and 13 cents.
Okay. Can I have every minute?
$2,718.28.
Okay. And can I have every second? Katie, do you have every second?
Sure. 2,718 point and 28 cents.
Uh-huh. Make an observation, people. What do you notice?
It stays the same amount.
Right, it starts to converge to the same amount, yes? So when you start to compound, so if I wanted to do every half a second, what do you predict the amount you would have after a year?
It'd be the
Yeah,
same.
closer.
It would be pretty close, right? If I said every third of a second, every fourth of a second, every fifth of a second. So if I were to compound this infinitely many times, what would your prediction be? Everybody.
Very.
It would stay the same.
It would be, wouldn't it? Okay. So now what I want you to do for me, whoops, get out of the way. What I want you to do for me right now is go, if whoever was assigned to what, do me a favor, just get me this value right here. Get me this value right here without multiplying it by 1,000, and you should all be able to tell me what it is without even doing anything, right? If you look at those numbers, right, this one here in green, what would it be? The 1 plus 1 over 730 to the 7th, based on this, people, come on. What would it be?
2.71.
2.71642. This one here would be 2.718, right? Because we're just moving the decimal place over 3 times because we multiplied it by 1,000 before, right? So this is 2.71828. And then again, this is 2.71828, yes? Okay, so this number here, so as we increase this, so if I did this, right, and I raise it to the nth power, and as n goes to infinity, we all know that this number, that this guy right here is going to go to this 2.71828. Are you all with?
Mhm.
Do you know who that is? Does anybody know who that is?
Isn't that like E or something? Like,
Huh?
The E, like
That is E, my friend. Yes. That is my favorite number next to 0. That is E. And E is approximately 2.71828, blah, blah, blah. So what I want you to do is grab your calculator, go to your division sign. You will see E there. So press the second division sign and you'll see E up there. And when you press E, what does it spit back out at you, friends?
Whoa.
2.178.
1828, 1828, blah, 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 blah. This number comes from the fact when we compound things infinitely many times, this is the beautiful number that appears. So that's what I was saying to you guys before, that this, oh my God, when n goes to infinity, goes to this number called E. Do you know why it's called E? Guess who discovered this?
Somebody whose name starts with an E.
You guys, somebody whose name starts with an E. You've heard of him before. Who is it?
the
You
imaginary,
Einstein?
What'd you say?
the imaginary number guy.
The imaginary number guy, yes.
Oh, not Einstein.
I forget his
Anyone?
name.
Anyone?
Euler.
Okay. Euler, you say it Euler, but you know, people, yes. So Euler was the dude who made this discovery that when you compound things continuously, so this represents continuous, oh my God, continuous compound interest, okay? It converges to that beautiful number. And if you were to take this and you were to write it as a function and do it as 1 plus 1 over x to the x power, you would have something that looks like this. And then over time, it's going to be asymptotic to this line right here. What's this line?
E.
Y equals E. You got it. It's going to be Y is equal to E. Isn't that awesome? And by the way, this is one of the most beautiful, oh my God, I'm going to put a happy face in there. Euler and that number E, other than 0, are my favorite numbers of all time. And as you embark on your mathematical careers, oh my God, and with me and with Mr. Killian and whoever you have, like in your calculus classes or whatever, you're going to find out just how awesome E is and the power that it brings. It is by far one of the most fascinating numbers and functions on the planet. Where? On the
Planet.
and beyond, by the way. It is amazing, okay? So, but before we do that, we're gonna spend a lot more time with E, but I just wanted to show you where he came from. Isn't that awesome? Can we just breathe in how cool it is that when I compound things, let's go back real quick. When we compound things, the more and more, whoops, was that our class? Yeah, it was. The more and more we compound things, right? The more and more we compound them, right? The more and more they start to approach a limit. The more and more they start to approach a limit. So these numbers, you're like, wait a minute, if I keep compounding, the more I increase this number, the more this is gonna kind of stay the same at that limit, which is beautiful. And that number, oh my God, which is awesome, is E. And that's where that beautiful E was discovered. Euler's the man, and I love him, okay? Now, things get compounded differently in different ways. So when we talk about compound interest, we're gonna do a couple more problems and I'm kicking you guys off to go and do what you gotta do and enjoy your weekend. So when I have something like this, times 1 plus R over N to the NT power, A represents your initial amount. What does R represent?
Rate.
Interest rate.
Annual interest rate, guys. So we're gonna say annual interest. What does N represent?
Number of times the interest is compounded.
Yes, number of times the interest is compounded. We're going to talk about 401ks, 403s. We talked about them a little bit at the beginning of the year, didn't we?
Mhm.
Okay, and T represents the number of years that you are compounding, okay? So, give me a number.
15.
Okay, let's go a little higher than 15, shall we?
15,000.
Okay, sure, we'll go 15,000. All right, you have $15,000. Where'd you get $15,000 from? You're 15 years old or 16 years old. Where the hell did you get 15 grand from? Where did that come from? All right, we'll give, all right, your mom and dad said, I'm gonna give you 15,000 to go put in the bank. All right, so let's say that you have that, your annual interest rate, let's say that you put it in an IRA, which is an individual retirement account that earns, let's say, on a conservative side of 2.47% per year, okay? Yes? And let's say that we compound, that it compounds daily. All right? So this is when you graduate. Let's say when you graduate high school, your grandparents, everybody's generous, you got $15,000. You listen to Mama Schwa, who said to open up an IRA when you're 18. It compounds daily. How much is in there after 5 years? Okay, how much is going to be in there after 5 years? So the first thing we're going to do is we know that our initial amount, this is our principal amount, is 15,000, right? And then 1 plus, our rate is 0.247, so that's going to be 0.0247 over, how many times are we compounding, friends?
365.
365 times, right? And it's going to be 365 times is the number of times we compound it, but it's over the course of
5 years.
5 years. It's over the course of 5 years. How much is in there after 5 years? I'll wait for you guys to tell me. And then we are almost done.
$16,971.68.
16,000. One more time.
971.
Yep.
And 68 cents.
And 68 cents. That's not bad. That's almost $2,000 in interest over the course of 5 years where you just put money in there. You didn't add any other money, by the way. We're going to talk about that later on, that you start off by putting $15,000 in, but likely you're going to want to add to it. So you'll be able to add monies later on, and we'll figure out what your monies will look like after that. So, all right. So Aaron, you know, your grandparents were generous. They gave you $15,000, right? You put it in this account that earns this. So now you want to find out how long it's going to take you to get to 20,000. Okay? So now we want to figure out how long it's going to take to get to 20,000. Does everybody have the interest rate and stuff like that so I can go to a new page? Okay, great. So now Aaron wants to make $20,000, right? He wants to find out how long it's going to take to make $20,000. So he's looking for time. Does everybody agree with that? When we're looking for how long, it's a matter of time when he's going to do that. So we know we're just going to do 1 plus, and what was it, 0.0247 over 365 raised to the 365, but now it's times time, because we want to know how long is it going to take Aaron to get himself up to 20 grand, okay? And this is based on not putting any money in. You know, you put 15,000 in, you walked away, it's earning 2.47% interest. That's it. So if you don't do anything or you don't add any money to that account, we want to know how long is it going to take to get to 20 grand, okay? So now we're going to be ready to solve. So we're going to divide both sides by 15. And what is 20,000 divided by 15?
1.3 repeated.
4/3. Let's leave it as 4/3. Just trust me there. You're going to leave it as 4/3, right? So 4/3 is equal to, and then let's add this together. And yes, you're going to put every single solitary decimal in because you want every single solitary dollar that you deserve. All right. I'm seeing 1.123. Is that 4 zeros?
Mm-hmm.
Okay. 67671. Do not cheat yourself out of any decimals here because we're talking money. Do you know what I'm saying, friends?
Mm-hmm.
Okay. So now this is an exponential equation. How do we solve exponential equations?
Logarithms.
Use logarithm. So how would I rewrite this as a logarithm?
You can go 365t equals log base, like whatever's in the parentheses, and then 4/3.
Yes. Okay, so let's evaluate what that is, because if you remember, right, I have y is equal to a, I'm sorry, if y is equal to a to the x power, for those of us who might not be remembering, so if I do y equals a to the x power, I do log base of y is equal to x, because I can take this and rewrite it in that form. So you guys let me know what you get when you get log base of all that junk. Okay, so it's divided by 3, and then 55, and oops. 1, 2, 3, 4. Okay, I'm seeing 42, 51, and 33. Divide that by 365. Yes?
Mm-hmm.
Okay. How long is it going to take Aaron to get to 20 G's?
It'll take me 11.65 years.
It's how many years? It's technically going to take 12 years, yes? If I wanted to say round to the nearest year, okay? Isn't that nice? So Aaron, if you take 15,000, you know, you're going to increase it by 33% in 5 years. See what I did there?
Yep.
Okay. All right, so any questions on this, my friends, so far? Isn't it fun that we know that you guys just met one of my best friends? Who's one of my best friends?
E.
Oh, it is by far. Oh my God, I can't wait, because I'm trying to figure out what we're going to do in the next set of weeks and how I can, oh my God, all the things I can do with you and what I have time to do and what I really want to do. So, all right. So I'm just going to